In this lesson of 10.6, we're going to continue, obviously, we're going to be doing circles this whole chapter, but we're going to look at segments more. We're going to look at chords, tangents, and secants, and we're going to be seeing how they're related to each other, not really dealing with angles in this section, not really doing arc length and all that stuff as much, just looking at how segments are related. So in this first theorem, we have segments of chords theorem. We have two chords. Okay, remember chords have endpoints on the circle, and they go through the middle of the circle. Okay, both endpoints have to be on the circle's edge. And so whenever we have two chords and they intersect, then it's going to form little segments that are also proportional, and we can make an equation in order to multiply them and be able to solve for a certain part. So we look at this first part, like we have AE here, okay, which is the EA, multiplied with EB, okay, so the parts of that segment, those two segments of that chord, multiply them together, okay, and it will equal the two parts multiplied of the other chord. So here we have EC and we have ED. Okay, so if I multiply the sections of the chord where they intersect, then it will equal the multiplication of the other one. So if we look at this problem, it says to find ML and JK. So first we need to solve for X if we're going to solve any lengths. And so if we look at this, we need to think about it. If we multiply the parts, then we will get the total. We will be able to equal them out. Okay, so if I look at this first, I'm going to look at the segment. Let's look at K to N. So I would do KN times the other half of that, or not the other half, but the other part of that chord, which would be NJ, would equal the other two chords multiplied together as well. So we have MN multiplied with the other side of NL. Okay, I multiply my parts of my chord, and they will equal each other. So when I do this KN, I'm just going to plug in my values as X. NJ is X plus 4, and I need to put that part in parentheses since it has that plus. MN is X plus 2. And then NL is X plus 1. So I need to multiply these. So here I'm just going to distribute this X. So I get X squared plus 4X. On my other one, if you want to do box method or if you want to FOIL, that's up to you. But box method would look like this. So I would do X squared, 2X, X, and 2. And so I would get X squared plus, if I add these two together, 3X plus 2. And then you're just going to solve. So if I subtract this X squared, it's going to cancel actually on both sides. So I'm going to go ahead and subtract this 3X as well. And so on the left side, it leaves me an X. On the right, I'm only left with a 2 because everything else canceled. So I get that X is equal to 2, but I need to know ML. So ML is this total length here. So I need to plug in both parts. So here, and I'm going to erase some of these other lines that we had going on. Okay, so here for this first one, I would plug in a 2, and I would do 2 plus 2, so this length is 4. Down here, we have 2 plus 1, so this length is 3. So if I add those together, ML is going to be 4 plus 3, so it's going to give me 7. So that would be the length of ML. For JK, it's the whole chord as well. So I'm going to plug it in. So if I go one direction, X is just 2, so I plug in my 2 there. Here I have 2 plus 4, so I get 6. So if I add those together, JK would equal my 2 plus that 6, and so the length of JK is going to be 8. Okay, this problem is a multi-step, okay, but you just need to make sure you're remembering that theorem that we just did. Okay, so multiply the parts of the chords to equal the multiplication of the other part as well. Here in this chord concept, it's going to go through some vocabulary. Chapter 10 is a lot of vocabulary. If you haven't been paying attention to it, that may be part that you're struggling on, I would encourage you to make sure that you're actually filling out the vocabulary part on your notes. And so a tangent segment is just going to be whenever you have a tangent line, when it's that external point all the way to our circle. That's our tangent segment. Secant segment is the whole thing from the point to the other side of the circle, okay, where it goes through it, and then it ends on the other side. And then we have the external secant, which is just another part of the secant segment. And so this is important as we start to look at some of these theorems, okay, just like how the last one, how we had a certain formula kind of that we could follow. It's going to work the same way for this. So when we have segments of secants, we're going to have two different secants in this problem. So you can see we have secant ED on this side, and then secant EB is the other secant. Those are our secant segments in this problem. And so all it says is that we would multiply the external part, and so here this is the external, EA, and then also EC. Those are the externals. We multiply them with the whole secant section, okay, and we equal them out. So when we look at a problem, okay, I multiply the external section with the whole, okay, and then I equal it to the other external section times the whole again. Okay, so if I look at this, writing them out, the external on the top is going to be RP. I multiply it with the whole thing, so the whole secant segment is going to be RQ. And so this is equal to the other side multiplied as well. So we have the external here of RS multiplied with the whole secant of RT. Okay, so once I have this formula, I encourage you to set them up this way. I can just plug it in. So RP is my 9. RQ is the whole length, so you need to add it together. So this would be 20. Don't be in a hurry and just put 11 real fast, because you know you multiply parts. Make sure you're doing the whole thing. RS is 10. And then RT is the whole thing, so it's 10 plus X. Okay, remember I add my parts to get my whole. So 10 plus X would be the whole length of RT. So then we just need to solve. So 9 times 20 will give you 180. On the other side, I need to distribute again. So I have 100 plus 10x. I'm going to try to solve. So I'm going to subtract my 100 here. So 180 minus 100 leaves me 80. On the right side, I would only have my 10x left. To get x by itself, I undo this multiplication. I divide by 10. And so x is going to equal 8. It only asks for the value of x, so that's it. And then our last theorem for this section is segments of secants and tangents. So if we have the tangent section, so tangent, remember, is an external point, and it goes where it's going to hit the outside of the circle once. It's not going to go through the circle. It's just going to barely touch it on the edge. And so the actual tangent segment is that point to the circle. And so here on the top we have EA is the tangent segment. And then on the bottom we have our secant again. We have the secant segment, which is the whole thing, and we have the external, which is the EC, the red part. So the formula for this one is going to be the tangent squared, the tangent segment squared, is equal to the external secant times the whole secant. So when we apply this to a problem again, we said the tangent squared, the tangent segment, so we have RQ as the tangent segment, so I would square it, is equal to the external, so the external is on the outside, so it's the RS, and then times the whole thing, which would be RT, the whole secant. So then I plug in my parts, so I have 16 squared here, RS I have X, and then RT, remember it's the whole thing, so I add up my parts, so I do X plus 8 would be the whole. And so then it's just a matter of solving, so we have 256 is 16 squared. Here I need to distribute, so I have X squared plus 8X. And so then our next step, this actually kind of goes back to algebra, okay? It's probably been a while since you've thought about this. We haven't had any problems really like this throughout this course. They kind of just threw this into this chapter, so we're just going to kind of review it. So in order to work a problem like this, when I have an x squared and it doesn't cancel out, I'm going to go ahead and subtract my 256 to the other side, because I want to get everything equal to 0. Okay, so when I do that, I get 0 is equal to x squared plus 8x minus 256. Okay. When I do this, now this is considered standard form. Okay, and like I said, this is a good review. You're also going to be seeing this next year when you go to Algebra 2 or if you go to Pre-Cal, whatever math class you're taking next. So, when I have it equal to 0, I can use quadratic formula. Okay, unless you know the roots of this problem and you can automatically do it, we just use quadratic formula. So I'm going to erase all this other stuff so we can fit it in. I'll just leave the equation down there. Okay, so quadratic formula is our, whatever your variable is going to equal negative b plus or minus the square root of b squared minus 4ac over 2a. Okay, so the letters respond to what's in the position. So whatever's in front of x squared, that is considered your a. So it's ax squared plus bx plus c. Okay, those are your letters. So when we use those letters, we just plug them in. So I would get negative, whatever my b is, my b in this case is 8, plus or minus, b again is 8, so I'd have 8 squared minus 4 times my a. In front of the x squared, there's a placeholder of just a 1. My c of negative 256. And all this would be over 2a. Okay, now my bad, I put in an a. Instead of 2a, you would put in a 1 for this case. Now, technically, we could find a rational answer for this. Okay, I'm not really worried about it, just because of the complexity of this problem anyways. I'm fine with you giving me the decimal. Okay, but when you put this in your calculator, you're going to have to do it one time with the plus. Okay, right here in this middle part where we have the plus minus. You're going to have to do it with the plus one time and with the minus the other time. Now, know that we cannot have a negative length. So one of these answers, when you put it in, most likely you're going to get a negative answer. The negative answer is not possible, okay? Or if sometimes you will get an error because it doesn't work whenever you put in these negatives. Then it's an imaginary solution is technically what it is. So whenever you put this in, like I said, you would want to give me only the positive answer. So when you put these in the calculator, these are the two answers you should get. You should get 12.5 and negative 20.5. Okay, but like I just said, we cannot have a negative length. So when you plug it back in, if we notice RS is simply equal to X, well, if X is one of these two answers, I cannot have a negative length, so 20.5 will not work. Okay, so my answer for this one is going to be 12.5. Okay, I will say on this problem, the quadratic formula, I'm not as worried about. I will not give you a problem where you have to work it this way. Okay, if I do, please come and just tell me, hey, do I have to work quadratic formula on this? And if I see it and I'm like, oh, yes, I will omit that answer, okay? I need you to know basically the process up to this. Like I said, quadratic formula is a good review because you will be seeing this again in your next math class. But I will not be doing problems like this because we haven't done it all year. So now if we look at example 4, this will give us another example. This one will not have quadratic formula, so it will not be as complicated. But we want to find the radius of this aquarium. So we know that if we find this point on the outside, they say they're standing there, they measure from themselves to the tank, and they say it's in the middle. And then they do a point from there to where it's going to barely graze the outside of this round tank. Then we're going to be able to solve for the radius. So the one that grazes the outside, that's our tangent. And so our tangent, in this case, is BC, so that's our squared one. And then we have our outside external secant portion, which is EC, the part that you do on the outside, times the whole length. And so if we add all this up, so we're going to add R plus 8 to get the whole length here. So it'll be R plus 8. That means we have 2R plus 8 is going to be the whole secant length. Okay? Or that secant length, if I was writing it just right now in letters like I was doing, then I would write DC. Okay? The whole length would be D to C. So if I plug it in, here I have 20 EC. I'm going to have that 8. And then, like I said, for DC, it's the R plus R, so that's 2R plus 8. 20 squared gives me 400. Then here I have to distribute, so 8 times 2R gives me 16R. 8 times 8 gives me 64. To solve, I'm going to subtract this 64 from both sides. And so 400 minus 64, I'm going to get 336. And then on the right side, this goes away, so I have 16R. Then I need to divide to undo that multiplication, so I'm going to divide by 16, divide by 16, and so I get 21 is equal to R. And so they asked for the radius, so the radius is 21.